Okay, so we're looking at the structure again. I want to bring your attention to the back wall here. The back wall, specifically we already talked about the rotation of the system right here. But right here, what is this? This line, if you will. I'll tell you, it goes to here, then it comes this way, then it goes down. Oh, it's conduit. Conduit is an electrical, it's a way to run mostly electrical wiring through it. Conduit. Why is it so important with evaluating this collapse? Let's see what I have over here to your left. So this is the structure, and there's that conduit right there. It goes across this wall, and it came this direction. But now as you observe it, it goes this direction, and now it rotates around here. Okay, let me get us back into that. So this is the easier view of it. Keep in mind already, I think they'd already been up here with the crane and knocked this down. But I don't think they went as far as reaching in there and doing anything there. I also want to say for a future video, which I'll say for now then, this is our tell on how the structure was at one point going down. This beam right here went across the top of this wall. And it's the top of, it's the top, same as the top of this one. But now it turns and comes this direction. Oh, wait a minute. This beam right here is connected here. And as you can see, behind this ductwork, I can show you in other images, but I will not today. You have to trust me on it. This beam connects and goes this direction, and then there it flaps down there. See how it's flapped down? Now, it's got this little T-bar thing going on. What is that? What is that? Well, cutting to the chase here, not much for riddles today, besides just asking. This, as you can see, the shape of it. See the shape of it? Almost like a 45-degree bend, break. This goes this direction. Let's go ahead and pull up this image. It's the same thing. Let's get you a magnifier over there and let's look at it kind of deep. Alright, so this goes over, it fits back up there, and it's probably somewhere there, so it's missing a block, and then there's a block there. As I follow it down, it's on the deck here. This is a deck. The concrete deck is still there. This deck here is still here, out to that ledge is what I talked to you about. There's a ductwork undamaged. That's why I can tell you it rotated first down and away. Now here's this T thingy. Now, I played around with someone on it for some time and finally gave it to him. Let's look at that. That's a parapet wall. Now I'm going to take liberty and come back towards us, but it's not down. It may look like it's down to you, but I want you to elevate it in the air, and then what's going to happen is it's going to turn in a hallway like this. And so right here is that one. It turns and it's a hallway, right? A corridor as they reference it. This is where this T-beam is, this section here. This concrete you're seeing here, if I put it back, it goes here and then turns and comes this direction. And there's that T. And it still has more rebar development on it, so it might go, the T might be right about there. And this might turn, it may not, it might turn back here or not, this rebar. So it might extend to back here. NIST could use some scaling software and scale that and see if they can determine, oh, well, you know what, that's the other part of the wall, this section, it makes it back to here perhaps. It looks like it makes it further back, like it turns. Like this might even be the roughly the turn there, I'm guessing. All right, so this is where the conduit, what I talked about a moment ago, this conduit here goes across this wall and turns. So it was flat against the wall at one point. Flat against the wall. And now which way does it look bent? Well, it looks like this, to get this to happen, it looks like I would have to, we're back to that rotation deal I told you about, where this box, axis 1, rotates away, which pulls away from this ductwork, but it shows you how far it would have bent over. It would have bent back here and buckled out the wall, like pushing your belly out. Buckled out the wall and push this rebar into a new configuration to this point. If the deck just simply fell forward, well, we wouldn't fall forward towards the pool deck area. Well, we would have the problem with this being torqued, and we don't get things like this happening, where we get this rebar turned in that direction. Rebar. The post tension, yeah. I'm doing this late in the morning. The conduit. We don't get the conduit turning. And then there's the conduit. You can see coming out of the box. Smooth this out of the way a bit. I'll just drop it down a bit for you. Actually, I should have just did that. Now that my magnifier's changed, I got to move it over a bit for the magnifier to work. So right about there is where it turned and went down. Probably a joint there that broke free. And there's your close in, more tight image. And there's a block. This block, if I'm going to gamble, did not come from over there, but probably right up here. Maybe here, and wound up denting the ductwork. Also, the buckling, and this, specifically this, probably smashed through the duct. Also helping it rotate away. As it smashed through it, it might have displaced it backwards a little bit, giving it more rotation, ability to rotate without damaging this end here. Without damaging the end of the ductwork. So the wall going down, turning, buckling, and this also breaking free. I don't really, it's a possibility, but I really just have it as pushing away, rotating away. That this didn't contribute besides when it tearing off the, smashing into the ductwork. Your beam here. I know you might think it's this one, but I think when I looked at it, it came to be this one. It still works for me, this turn. If this piece is this, I remember it being this, though, as I look closer in another image. If it's this one, still, it went this direction and turned and came back. This is the only way you're going to get this coloration, this T, which shapes like this color here. That's the outside wall, to be there. If you try to put this back up straight, it would be way out there, and this doesn't work. Now, it could work if it was if it reached into the outside wall, but this is not the outside wall. Just for clarity, this is the inside. I'm going to get rid of this now. This is the inside wall. This section here that ties into this one. This is where that beam went across. Remember, we had a beam that I said cantilevered over. Well, there's a beam that goes across, and then the other beam meets it from there. And a cantilever, and it meets this one here. I'm doing and this one comes back and turns. This is the roof now. This section here becomes the roof, and let me do the inside wall. I should change colors. Can I change them fast enough? I don't know if I can. Yep, I can. So this is the. I'm going to take a liberty by making it proportionally wrong. This lower half should be wider, meaning this corridor is now more narrow than this corridor. If you want me to give you a little better idea, it would probably be like that. This goes all the way across to that wall there. And it's a column. I'm going to make some round columns perhaps. Let's see if I can change the color of that. Yeah, whatever. Get out of my way. This is in the way. There we go. That didn't work. Yep, got Georgie behind me. There we go. Go pink. And then there's a column there. And there's a column here, I believe, that goes down to the shear on top of the shear wall. This one probably supports on top of. And then the beam for the back wall that was with the door cantilevers from, let me take some liberty here, right about here. And so it cantilevers from there, and so you've got to, okay, then I'll do another beam for you to help you see it better. But this time I'm going to turn it so you can see it, which is kind of weird. All right, so I ran that back to, Yeah, that was the question. It ran back to here. Let's do that one. So it ran back to here along with this one cantilevering, and then the roof deck comes over. I don't know if this exists, so that's what I'm wondering. Did they put that back there, or did he just somehow do another cantilever across here, and this made another cantilever action? This little thing right here, this section here, or is this like that? And then this one coming across. This one coming across might have made it to the shear wall also, which then gives you the point to anchor into. So this one. That's the way I see it. I think that's the way it was worked. And then this one probably went down to there. So now rotation, you can see right here, we got this issue. We got the ductwork coming in, the hallway right about here. So of course I'd have to, they knocked this down already, but the ductwork would be coming in somewhere about over here. Interesting, I found another piece. This piece here, right on top of that, has a nodule or something sticking out. If I can locate where that is in the before collapsed image, then we can triangulate exactly where this little built-up extra reinforcement was done. Because this appears to be concrete and then block wall and then a solid fill tying into the beam there. This section, this little piece there, that little piece there. And if I get rid of this stuff now, it might be that this piece fit right over there, that your ductwork fit on this side of it. And I'm not sure if it fit on this side. I like it for this side. And then they blocked underneath of it, closing the wall up. But for some reason that got extra reinforcement and solid pouring. Maybe they didn't have sometimes they stuff these with paper just to make the cap back then in the 80s. So maybe this one concrete just kept going down. They were like, yo, stuff it down and just push down 3 courses and just fill the top 2. Or in this case, top 1. This more than likely did not have, maybe it just had a block with the notches in it, and then they filled it. Not a solid formed up piece of concrete, just so you know. All right, this is that one. Now let me do this. You know what, let me do this. So delete that. Let's do the conduit on this one. And let me add the text conduit. Yeah, that works for me. I like spell check. Great. Let's do that. Conduit, let's see. Then I'm going to grab this little arrow if I can. So that conduit tells a heck of a story with its bend. It's just, so the bending reaction is really, it's back here is where it broke the strap. And it's really bending right about there. Somewhere about this zone here is where it's bending from. So I have to grab the pipe, pull it off. That's where it took its bend. It's really not here. This is still about at 90 degrees right here. That's still 90 degrees. Okay, so that's a telling thing that we don't have. You're further behind it to get this to bend, push it, rotate in. To get it to rotate in, we have the wall buckling out. You know, the deck's falling inwards, and that's buckling out. Let me screenshot this one, and I'll get us out of this one. So let's do that, and let's revert, and then get rid of it. Close document. All right, so we're back to this, and this is what I wanted you to be mindful of. What I came here to show you, this conduit here. Now I have another piece of conduit on the other wall. It tells part of the story. It's not in this video. Let's see if I have what I have over here ready for you. Same thing, and one more tab. And yeah, same thing times 3. All right, just allowed me different magnifications when I think I worked with this one. Yes, it was. So we've got that. Now I'll end the video with this. I've added this in another video previously, but I want you to look at these fracture lines here. They're at the floor. See the balcony? They're at the floor, at the floor, at the floor, at the floor. Now here's the roof going down, and look up here. There is no, they didn't do that up here. Well, these floors, I would theorize that they had more load on them from the floors above at that point. So much stress that it was able to tug on this wall, on the floor system all the way across before it separated. Tug, tug, tug. I mean, it was a hard, more loading as it goes down. Tug, tug, and tug, tugging across the slab like tug-of-war all the way across. And in fact, down here is where that building took a little shake, and you can see where it separated the outside almost fully up to oops, looks like it was magnified, up to the 4th, 5th floor. So 1, 2, 3, 4, 5, somewhere about there. Maybe it's turning, going down here like this. I can't get any. Yeah, I can. Yeah, maybe I'm seeing ghosts, but it looks like this to me. Not sure if you're seeing it too, but that's the pattern I'm starting to see here. And then this is straight down. Again, if you look up here, you don't see that tugging. So it talks about the load being on the roof first, going down like that. I worked my heart out to try to see if I can get the buckling column, specifically K or LM and N, O also. If I can get that to buckle, and also the roof at the same time. That's the way the images video presents. I cannot. But I will say that I have a nice data from that video. I'm trying to enhance it for you now. To sort of tell you that after this went down up here at the roof line, over here, rotating down, there was some material still left here that came back and recaptured and fell again. This is in the video. If you look at it, the building's pretty much, this section over here is collapsed, and then all of a sudden you see what appears to be more debris falling over here. And so it's like this section here. It's like this section here is my main course of issue. Now, with that said, in the video, it looks like it's all the way over to O when we start seeing, when we observe the roof going down. And Charles, by chance, sent me an image baiting with me on this, showing me that he looks like he has an image with the building just before the collapse that the top floor is intact. He can't verify the image, but he said that he thinks he got it from that video, from a freeze frame. I'm like, my God, that's beautiful if it's true. So I'm trying to verify that with him now. It would be very interesting because that means NIST has access to the original content that shows the entire building, not the ground, not the floor, not the pool deck, the entire building in its state from start to end. And they can clearly use better software to freeze frame it. We're looking at uploaded video to YouTube, which is a different encoder than the original one that they have access to from the building itself. So that one's the cleanest file you can work with. We're looking at a file that's been encoded again, and it's not as good as what they have. So this video again was about this piece of rebar here, identifying it. This piece here, it puts it back to here. Now I'll do this. I'll come back to this. So there's that rebar right there. And it didn't bend here, it didn't push in there, but if I push the wall in here, if I start rotating this down, remember my box video I showed you, I start rotating down, I kick it out, and I only kick it out so much, it only comes in plane just so much, into our zone here, not much out of 90, so there's the 90, and it only comes in, by buckling, I'm just guessing here, maybe 2 feet, that could even be that, when the wall was buckling, that half of the buckle and the top wall was able to do a nice shove before it went down. But nevertheless, it's indicating that this rotation this way. And that gives us a break from here. That's what I mean about that little part that goes down. Might be right here, a little T-bar. And see that little nodule right there? That little hickey? I can't zoom in anymore. That hickey right here is what I'm saying the hickey is. Right there. Yeah. So that little teeny hickey right there above my mouse, above that little negative thing. I'm thinking that little teeny hickey is this thing right there, which now tells us so that's that wall that turns this way, comes this way, and that little T-bar thing. Ductwork seems much lower than where I would think it would be. I mean, where I stated. So coming back to here, there's that hickey. So we come this way, come back to me, and this is where this was. That was. This and that were in line with each other, presentatively right here. Arguably, how about that? So again, that puts it like bumping out like you bump your ass out, if you will. And then that gets us at a plane, at bending. But the bend's back here. So that puts us sort of here now with the collapse. Again, back to this box. I've triangulated this differently with an open mind, trying to debunk myself. And all I do is find more data that says that this is the collapsing zone, this area here. Perhaps when the building shook, perhaps this head couldn't hold up, but I don't know how this head was anchored down. This is a head too. That's another video. We're going to talk about that head there also on the roof. And I'll end that video with this, and hopefully you love it. This is anchored down. I believe it's a tie-down anchor. Had to meet 150 miles per hour winds, I think, was a requirement. So it's probably a tie-down. Yeah. Take care, guys. Love you. Bye. And thanks for, being members. Looks like we lost one member. I guess they, I don't know what they wanted. They were quiet. Don't even know who they were. They dipped in and out. Okay. Take care. Love you still. Bye.